I probably won't. I'll be just fine. This feeling inside my bones. To me, turn it on. All right, well, maybe we should get going. I forgot my phone upstairs, so just played the radio. What do we got? We got Polar today. Polar. So let me share. Share. All right, away we go. The graphs of the polar curves r equals 3 and r equals 3 minus 2 sine 2 theta are shown in the figure above for 0 to pi. So they only graph these from 0 to pi. Let r be, actually I got it split up so I have more room. There we go. Let r be the shaded region that is inside the graph of r equals 3 and inside the graph of r equals 3 minus 2 sine 2 theta. Find the area of r. Now they're not asking for the area in between, that's here. They're asking for the area under the first curve, that's from 0 to pi, and then at, excuse me, pi over 2. And then after pi over 2, we're going to follow the circle. Need to get this out of the way. So on letter A, first of all, to find the area of a polar curve, it's 1/2 integral from A to B of r squared d theta. Because the area of a sector is 1/2 r squared theta, but the d theta takes care of the angles when we do the integral. So here's what we need. We need 1/2 integral from 0 to pi over 2 of this first curve right here, the one that's not a circle. So 0 to pi over 2. Now, if they wanted the area in between, then we would be subtracting the 2. We'd take the 3 minus the other one, but they're not asking for that. All right, so we need 3 minus 2 sine of 2 theta, and we need to square that, d theta. So that's from 0 to pi over 2. But then after pi over 2, we're following, the area follows this circle. So then that's a quarter of a circle. So we have 1/4 pi and then times r squared, which is going to be 9. Now this is a calculator problem, so we're going to let the calculator do as much of the work as possible. So 0.5, math number 9. 0 to pi divided by 2. And I need, oh boy, 3 minus 2 sine of 2 theta. And then we need to square that d theta. And I think I'm in radians. Yep, in radians. Press enter, and then we go plus 9/4 pi. And I'm getting 9.707. I got the answer somewhere. Let's make sure that's right. Yep, there we go. 9.707 or 708, either one. So 9.7070. Somehow my computer just started lagging about 10 minutes ago. So bear with me on this. There's letter A. Letter B, for the curve r equals 3 minus 2 sine 2 theta, find the value of dx d theta at theta equals pi over 6. So we need, if we're going to have the derivative of x, we need x. Well, x is equal to r cosine of theta. And just as a side note, okay. And then y is equal to r, geez, it's lagging, r sine of theta. I wrote an S and it wrote a straight line. We just need the x here. So x is equal to the r. The r is 3 minus 2 sine. So 3 minus 2 sine of 2 theta. And then times cosine of theta. Now we're going to take the derivative and we're going to evaluate it pi over 6. So we just need dx d theta. And we're just going to write down that we're evaluating the derivative of this when theta is equal to pi over 6. So even though we're going to use a calculator, still writing down what we're doing. So math number 8 gives the value of a derivative at a certain value. So this is, oh, I need the function here. All right, so 3 minus, that's a plus, minus 2 sine of 2 theta, or 2x here. Not squaring this time, but I need parentheses around there because I'm multiplying times the cosine of x. And we're evaluating at pi divided by 6, right? Yeah, pi divided by 6. Oh, I thought, how come did I type something wrong there? Maybe someone can see it. Oh no, it is a decimal value. Oh, here's where we get -2 on the next one. I was like, I think we get -2, but that's the next. So this is equal to -2.366. The distance between the two curves changes for 0 to pi over 2. So if we look at the distance as we're going around the unit circle, so to speak, the distance between these two curves is changing. And they want to know, what is the rate of change right at pi over 3? Like right here, what's the rate of change about right there? Find the rate at which the distance between the two curves is changing with respect to theta when theta equals pi over 3. Well, the distance between the two is going to be from the pole to 3. So that'll always be 3 units. And then minus the other r, or the other equation, which is 3 minus 2 sine of 2 theta. So the distance is equal to, we got 3 minus 3 is 0. So 2, geez, it's lagging. 2 sine of 2 theta. But we want the rate at which the distance between the two curves change. So we want the derivative. We want the rate. So we want dd or d theta evaluated when theta is equal to pi over 3. And I could very easily take the derivative of this. But if it's a calculator problem, don't do that. Just let the calculator take the derivative of it so that you don't make a mistake. Derivative with, we'll say x because we're going to use variable x. And it's going to be, we're taking the derivative of 2 sine of 2x. And we're evaluating at pi divided by 3. I think this is the one where we just get it rounds to 2. So they're doing -2. It's actually -2 is what they're doing. right? Let's take a look at the rubric, make sure I'm doing this right. Yep, -2 right there. So there's letter C. Letter D. A particle is moving along the curve r equals 3 minus 2 sine 2 theta. So that d theta dt is 3. So they kind of give that to us. For all times t greater than 0, find the value of dr dt at theta equals pi over 6. Well, if you look around, we don't have anything with respect to t. So we have to build this. We're going to do dr. We have dr d theta. I can take the derivative of r with respect to theta, and they give us d theta dt. So multiply by d theta dt, and these differentials work kind of like variables or values. And so that's what they're asking for. dr dt is equal to this combination, this multiplication. So we want dr d theta at pi over 6. I think we just did that. We did dr d theta. Oh, no, that's the distance one. Where was dx? Oh, I thought we already did it. I thought that's how we got. No, we didn't. Maybe we didn't. Okay, so we want this evaluated at pi over 6. We want dr d theta. All right. So math number 9. No, not in math number 9. I'm not doing real well today. Math number 8. And we want 3 minus 2 sine of 2x evaluated at pi over 6. Pi divided by 6. And what do we get? Oh, we get that -2. That looks familiar. Maybe I did do that. You're probably sitting there yelling at me. -2 times, and then they give us the 3 right here is 3 -6. I know that's the answer. There we go, -6. Let me know if you have any questions in the comments, or unmute yourself, of course. So there's polar. Here's some other random subjects that I thought could possibly be on the test. The growth rate of a population P of bears in a newly established wildlife preserve is modeled by the differential equation. And this happens to be the form of logistic. This is a logistic equation where T is measured in years. What is the carrying capacity for bears in this wildlife preserve? Here's the carrying capacity right here. So 100 bears. Jeez. Oh, computer, stop lagging. Holy cow. What is the bear population when the population is growing the fastest? That's always half the carrying capacity. So 50 bears. What is the rate of change of the population when it is growing the fastest? So it's growing the fastest when P is 50. So the rate is the fastest when the population is 50. So we're going to plug 50 in, starting to lag. And then, times, I'll do this, 100 minus 50. And so I did this earlier. I think it's 20.008 times 50, and then times another 50, because 100 minus 50 is 50. So it ends up being 20 bears per year. That's when the rate is the fastest. This one is typically a multiple choice question, but in the past, AP has really liked this question. Given the chart above, find F inverse prime of 3. Well, F of 2 is 3, and that's right here. F of 2 is 3. So that means that F inverse of 3 must be 2 just by inverses. That's how you get inverses. You switch the X and the Y. Well, if F prime of 2 is 5, and that's from the chart over there, inverse functions, the derivative, the slopes of inverse functions at corresponding points are reciprocals of each other, which means that F inverse prime of 3 at the corresponding point, these are corresponding points, is equal to 1/5. If I had to guess, this is probably not going to be on your test, but I'm trying to just cover everything. I can just go off of past years, and that's all we can do right now. I have no idea what's going to be on this new test this year in this very strange year. The graph of f of x is equal to x squared is given. The secant line from point 0, 0 to 2, 4 is also given. Find a value for x where the slope of the secant line is equal to the slope of the tangent line on the interval 0, 2. So really what we're talking about is the mean value theorem, is what this is demonstrating. Mean value theorem. And we want to know, here's the graph. Here's the curve is x squared, and here's the secant line from 0 to 2. Now we want to know where is the tangent line the same. And I'll just tell you right now, it happens to be 1. The slopes will be exactly the same. But to do the math, we do the derivative of the function, which is 2c. It's lagging so bad. 2c is equal to, that's the derivative, but we usually assign the value, the variable c for the mean value theorem. That's what we're trying to find right there. Is equal to old-fashioned slope, 4 minus 0 over 2 minus 0. So y2 minus y1, x2 minus x1. So 2c is equal to 2. C, here's that 1. C is equal to 1 right there. So that's where the slope of the secant, slope of the tangent line are the same. I already did that one. How about a related rate problem? A spherical balloon is inflated with helium at a rate of 100 pi feet cubed per minute. So really this is dV dt is what they just gave you. How fast is the balloon's radius increasing at the instant the radius is 5 feet? So for letter A, the only information we really have is dV dt, so we should probably start with the volume. So dV dt is equal to, the derivative of this is going to be, those 3's will cancel. So 4 pi r squared, because we're going to reduce the power by 1, and that's going to be dr dt. Now we know that dV dt from the reading is 100 pi. That's equal to 4 pi, and it says when r is 5. So that means that's going to be a 25 there, dr dt. Well, that happens to be 100 pi. So the rate at which the radius is changing is 1 foot per minute. Because if the volume is cubed, that's a a 3-dimensional measurement. A radius is only a 1-dimensional measurement, linear. B, how fast is the surface area increasing at that instant, referring to letter A. So ds, the derivative of s with respect to t, the surface area, is 8 pi r. 8 pi r, but if we're taking the derivative with respect to t, then we have times dr dt. So ds dt is equal to 8 pi, r is 5, but we just found out that dr dt is 1. So times 1. So we get 40 pi, and this is surface area, so that means we have feet squared per minute on that one. So a related rates problem. Thought we could visit that a little bit. And then the last one is the fundamental theorem of calculus. It seems reasonable that they would have something with the fundamental theorem of calculus, but that could just be doing some sort of integral. But here we have the derivative of the integral, and those undo each other, kind of. And here's what you do. You take x squared, you plug that in for any of the variables. So we have cotangent of 3x squared. Now imagine we did the integral and plugged that x squared in, but then we did the derivative. What we would have is we'd have the integral of cotangent would be something. The derivative would be go right back to cotangent with 3x squared in it, but then times 2x. So you can consider this the inside. So that we have to do the chain rule. So that's the answer right there. You multiply by the derivative of this, not the derivative of that. I've seen that. I've seen answers of 3 cotangent of 3t, which is, that's not it. You don't take the derivative of this, you multiply by the derivative of that limit up there. All right, kind of short notes today because I only have one of the free response for the polar, but I just sent you this probably right before class started. This is your testing guide, and I'm gonna stop. I'm gonna unmute you all as long as there's not a ton of background noise. I don't know if I have any additional information that this wouldn't have as far as your test is concerned, because I just like you, I haven't lived through it either. So it gives you a summary of resources. This should be in your email. There's a checklist, required documents. There's going to be a demo that we're going to go through. I got to get more information for that so that we can, I can make sure we get that done so we can practice this. There's an e-ticket. There's 5 steps: exam day, exam scores, credit, and placement. So your e-ticket, apparently you're going to get a ticket through the email. Now, you were asked to change your email from your school account to something else, and then the tech team was able to fix that so you can get email from AP. So now you've been asked to change it back to your school email. So make sure you do that. I mean, if you want to take this test, you're going to have to do that. And I believe because that's how you're going to get all the information. You're going to get the ticket through your email. So make sure you go back and change that. They're valid for the May exam. Here's the makeup dates, and you can look through all this. What to expect on this year's exam. They tell you how it's really, they don't think it's going to be any more difficult or any easier than any other year. I don't know how they can judge that. So you can read through what they're telling you. They're trying to, don't worry, just take it and do the best you can is what I gathered when I read all this. The message is do the best you can. You'll be fine. What to expect on this year's exam. I don't know how this, I don't know. So AP teachers will have the chance to review your score and your exam responses this summer. If you don't receive a score of 3 or higher and your teacher is convinced you should have, I'll be able to go through some process. Not sure what that's going to have to look like. That I'm sure that will be in cooperation with the administration also. So I don't think I would have really the final say on that. That's very odd. I've never seen that before. But yeah, it seems like I can fight for a better grade if I think you deserve it. The exam questions are viewed by students in a web browser like Chrome. Students type or write their responses outside that browser. Then they choose from 3 options to submit. So you can copy and paste. You can attach a typed response if you want, or you can take a picture of it like we've been doing for tests. So the good news is with Google Classroom, we've kind of been practicing this already. I guess that's great. And then it talks about the 3 different ways, the 3 different options, and please read through that so you have an idea of what's going on. Now, apparently music theory and world language they have to do those a little different. I didn't even read that because I don't teach those. If you have any kind of accommodations, you can read through this. You can request a makeup exam, and then they have 5 steps to take before exam. Review your contact information. That would be on their website. They're saying, make sure you have it right so that we can send all this to the right place. We're going to practice later on, receive exam confirmation e-tickets, check your technology, and then gather what you need for each exam. And then you can kind of read through this. I don't need to read this to you. I know nothing more than what this actually says. But I just wanted to point it out. I sent this to you. They probably sent it to you. I don't know. Here's what you need on exam day, about optional resources. So this seems like a lot, but it's really big print, and I think this would be a quick read for you. Your testing environment, exam security. What I can tell you and what I've heard is that they're going to run this through almost like a math version of Turnitin.com, where they're going to see if you sat there and Googled stuff. With the time restriction, I don't think it's a good idea to try to cheat the system at all. I think you're very well prepared. I don't mean to kind of brag, but my students have done very well in the past. I just don't think you need to risk it. really, they can, and don't quote me on this, but they're also, I believe, responsible for ACT. So if you're caught cheating on your AP exams, I don't know if they could do something, hold your ACT or nullify it, or I don't know. And don't quote me on that at all. But I would not risk uh, plagiarizing if you could even do that on this test. Just make sure you're doing the free response questions. Make sure you're studying for my quizzes. Make sure you're doing, even the minimum that I ask you to do. And I think you're going to be pretty well prepared for it. I don't think attempting to cheat on this would even be necessary. As a matter of fact, I think right now, if you took it right now, I think the vast majority of you would do very well. So that's my little pep talk to not cheat on this test, to give it your honest attempt. And I think that is the best way to go, because then I don't want them coming after your ACT or coming after you academically in any way. That's not how you want to start your freshman year in college, is having to worry about what College Board could possibly do to you. And that's not a threat. I have no, I don't know what. I'm just looking out for you guys and try to motivate you to just be honest on this and to be confident that you've been prepared to take this test. All right, short notes today. That's all I got for you. Any questions? Get the free response questions in, and then the quiz is going to open up Friday morning at 8 a.m. So you got a day to look back at those free response questions and study for it a little bit. There'll be 6 multiple choice questions as usual, and we'll just keep on keeping on. If there's no questions or comments, have a great day, and we'll see you on Monday. Bye-bye.